So we're going to learn about limiting reactant, what that means, how to solve problems with limiting reactant, and the two things you always need to find in any limiting reactant problem. Limiting reactant, okay? Limiting reactant is not difficult. It's also sometimes called limiting reagent. Okay, you know how we like to have multiple names for the same thing. Literally means the same thing. I just want to make sure that you see both just in case, okay? And we all know what this means actually, okay? Limiting, things that are limited, right? It means you run out. If you have limited time, it means you've run out of time, right? You don't have unlimited time. If you have a limited budget, it means you don't have a bajillion unlimited dollars, right? You only have a certain amount of dollars and then you run out of dollars if you've spent your limited budget. That's exactly what it means in a chemical reaction, okay? I have a limiting reactant or a limiting reagent. I run out of reactant at some point. I hope that makes sense, right? We don't have unlimited resources. My reaction is eventually going to come to a stop and I need to figure out when it stops, how much product do I actually make, and which reactant did I run out of, right? Which reactant is the limiting? So always there's going to be two questions to answer for any limiting reactant problem. Even if it doesn't say it in the problem, you should be able to figure this out, okay? You should be trying to figure out these two questions. Question number one, all right, is how much product can you actually make? You actually make. And question number two is which reactant is the limiting? Okay, so two questions you should always answer for any limiting reactant problem. Okay, and just more terminology. Okay, so the limiting reactant we will abbreviate as LR. Big capital L, big capital R, limiting reactant. There's also the excess reactant, meaning you didn't run out of it, right? You have excess of it. There's more left over. You get it, okay? And we abbreviate that as extra small, okay? XS, excess, okay? So just so you see these terms. All right. And the best way to talk about limiting reactant is, of course, with s'mores. And I wish that we were together and not quarantined with all of this craziness, because I would bring s'mores for you, but at least you get a picture of them. That's just as good, right? Okay, so to make a s'more, you need 2 graham cracker pieces, right, for the sandwich part. You all know how to make s'mores. 1 marshmallow and 1 beautiful chocolate piece, right? You layer them all on top of each other. And boom, you have a s'more, okay? If I had 2 graham cracker pieces, 1 marshmallow, and 1 piece of chocolate, I can make 1 s'more. That's it, right? I've used up all my reactants and I've only made 1 s'more. If I have 2 chocolate pieces and all this stuff, it doesn't matter, right? I can still only make 1 s'more and I have excess chocolate. I'm limited in all of my other reactants. I've run out of my other reactants. I can't make another s'more, okay? I could literally go out and buy the whole store's worth of marshmallows, okay? I'd go buy 70,000 bags of marshmallows. It still wouldn't matter, right? I can only make 1 s'more with these reactants, right? I only have 2 graham crackers. I have 1,000,000 marshmallows and I have 2 chocolate pieces, okay? It still doesn't matter. I can only make 1 s'more because I am limited in one of my reactants. What do I run out of? I ran out of graham crackers. What do I have excess of? I have excess, a lot of excess marshmallows and excess chocolate, okay? So my limiting reactant, my LR, in this case, would be my graham crackers. My excess would be both my marshmallows and my chocolate, okay? So hopefully it's at least a visual to see, okay, I run out of stuff, right? Okay, so let's look at a for real example. We'll just do an easy example. We'll save a harder example for a different video, okay? So if we have, of course, this equation, my favorite, okay? And we're told in our problem, we have 15 moles of nitrogen and 15 moles of hydrogen reacting. How many moles of NH3 are actually produced? Okay, so this would be the problem. They're giving you an amount of one reactant and an amount of another reactant. Okay. So here's the basics, okay? Your number of reactants in the problem is going to be the number of limiting reactant stoich problems that you complete. Okay, so in this case I have 1, 2 reactants, so I'm going to do 2 stoich problems. Okay, if I had a reaction that had 3 reactants, I would do 3 stoich problems. If I had you get it, okay? If I had 72 reactants, I'd have to do 72 stoich problems. Obviously we won't give you that, okay? But my number of reactants means that's the number of stoich problems I'm going to do. And then I just follow my rules, right? I have 5 rules to complete, to solve any stoich problem. Rule number 1, balance your equation. Okie doke. 3 here, 2 here, okay? Rule number 2, start with my given. Well, I'm given 2 different things, so I have to have 2 different problems, right? So I'm going to start with 15 moles of N2 for one problem, and I'm going to start with 15 moles of H2 for the next problem, okay? Cool, so I'm starting with my givens. Step 3, if necessary, convert to moles. Not necessary, already in moles, got it, okay? Step 4, do your mole ratio. Okie doke. All right, so in moles of N2, I need to get out of moles of N2, and I want to figure out how many moles of NH3 I make. Okay, so, and I would do the same thing for H2. Get out of moles of H2, get into moles of NH3. And I just use my balance coefficients. So N2 gets 1 mole of N2 for every 2 moles of NH3, 3 moles of H2 for every 2 moles of NH3, okay? And my last step, if necessary, convert to the units the question asks. Question's asking for moles, okay? So I don't need to convert, I'm gonna be in moles of NH3. So those guys cancel. And I do some sweet math, 15 times 2, 30 moles of NH3, or 15 times 2 is 30, divided by 3 is 10 moles of NH3, okay? So now what the heck? I have 2 options, okay? In limiting reactant, remember, I'm limited, okay? This is a limiting reactant problem. So this is chemistry golf. Lowest number wins, okay? So if I'm looking at these 2 options, I pick the smaller one. Boom, 10. You can only get the limited amount, okay? So your 2 questions that you ask at the beginning, right? Question 1 is how much product can I actually make? Smallest amount wins. Chemistry golf. 10 moles of NH3 is what I can make. Question 2 is which reactant is limiting, okay? Which reactant is limiting? I cannot tell you how many people will say the limiting reactant is NH3 because they look what's in their box and they say this. NH3 is the product, okay? Please don't be that person, okay? At least pick one of the reactants for which is the limiting reactant. The way you figure out which is your limiting reactant is you just look at your answer and you work backwards to figure out which reactant did you run out of? I ran out of H2. So H2 is going to be my limiting reactant, or hydrogen is my limiting reactant. And you could also say, N2 is your excess. You're going to have leftover nitrogen at the end. Okay, so not too complicated. We'll do a harder one in the next video. Yay.